now. All right, 2-3, analyzing graphs of functions. Use a vertical line test. Is that okay? Y'all good with the vertical line test? Cool. What are zeros of a function? What are the zeros of a function? X-intercepts, right? So we're going to calculate zeros of a function. How do you know when a graph is increasing or decreasing? It's increasing when it is, and it's decreasing when it is, and it's constant when it is. Yeah. Do you know what a maximum is? A maximum, yeah, it's way down. No. Okay. Okay. What about a graph that if it looked like this? Can you talk about maximums and minimums there? Can it have more than one? Okay. We're gonna throw in another extra name, right? I mean, this graph clearly has a maximum, right? But relative to the spaces around it, this is a maximum. So this is a relative maximum. Easy stuff. What's an average rate of change? That's what we're doing today. Okay. So we're going to study functions from graphical perspective. We're not studying them from algebraic. We're going to talk about what the graphs are doing. What does it look like? Okay, a graph is made of a bunch of ordered pairs, x, f of x. They don't use the letter y a lot in this text, I've noticed. So instead of using y, they're calling it f of x. That's fine. So instead of x, y, they're saying x, f of x. Same thing, right? Okay. It's just what is y. So here's a graph. X is the distance from the y-axis, right? And y would be the distance from the x-axis. No big deal. Easy stuff. Remember the difference between an open circle and a closed circle? An open dot and a closed dot? Okay. So looking at this graph, let's talk about the domain and the range real quick. The text is going to come back and talk about it as well, but I want to talk about it right now. So domain includes what? What is the domain? All x values, right? So looking at this graph, can you tell me the domain of this function? What is the smallest x value? What is the biggest x value, right? -1 up to? Okay. Okay, talk to me about brackets and parentheses. Okay, so a bracket means it's equal because a bracket has a built-in equal sign, right? So there's an equal sign right there. So a bracket, it can equal -1. Can this equal 5? Okay. Talk to me about the range for this guy. Small to large, please. -3 to 3. Why brackets? Okay. Yeah, and normally though a graph is going to have a curve. It's not actually going to have a solid dot there. We're going to a lot of times assume that the intent was that it touches that line. Okay. And of course, when we're using technology, we can actually calculate the maximum and the minimum right in the calculator. No problems there. Questions so far? Moving right along. By definition of a function, at most one y value corresponds to a given x value. We usually say it the other way around. We usually say for every x value there is one y, right? And if there's 2y for one x, it's not a function, okay? So a function cannot have 2 or more different points with the same x coordinate. No 2 points on the graph of a function can be vertically above one another. And it follows the vertical line test. So here we go with the vertical line test. Vertical line test tells us if we pass a vertical line across a function, If it touches it more than once, it is not a function. All right. Okay, so this graph, we've already done parts A and C, correct? We already talked about the domain and the range of this function. The graph asks, what is the function value f of -1? So what is the value of f of -1? Okay, what exactly is the question asking? What is x when y is? Okay, and so what is y? What is y when x is? What is y when x is -1? And it is 1. What is the value of f of 2? When x is 2, y is? Did I lie about today being easy? But wait, there's more. Okay. Here are the answers. We've already done it. Do what? It can be. Is it too zoomed in? Okay. You want me to unzoom it? Is that better? Is it unzoomed now? Yeah. Okay. If the graph of a function of x has an intercept at 0a, then a is a 0 of the function. So we know to find the zeros of a function, at all zeros of a function, the value of y is 0. Okay. There we go. Okay. So let's find the zeros. So the first one, it's kind of the work's done for us here. I'm going to write in a couple extra steps here. The function is 3x squared plus x minus 10. I want to know the x-intercepts. I want to know the zeros. Well, to find the zeros, you let y equal 0. So by changing f of x to 0, we get 3x squared plus x minus 10 equals 0. And yeah, we have to factor it. Factoring hasn't gone away. Okay, I'm hoping by now factoring is getting easier a little bit. Okay, so let's go ahead and add some steps in here to see. I mean, they went from the problem to the factored answer. Okay, are y'all able to do that? Okay, so what did we do here? What is AC? -30. Which means I need a product of -30 that combine to what number? 1. Okay. So what two numbers multiply to get -30, but add them together, I get 1. Multiply two numbers, huh? Multiply two numbers together to get -30, but add those two numbers and get 1. 6 and -5. Okay. 6 times -5 is -30. 6 plus -5 is 1, right? So if we were doing this by grouping, I would write this as 3x squared plus 6x minus 5x minus 10 equals 0. Okay. Did I show y'all how to factor doing illegal math? Okay. So you might want to jot some notes down on this. I'm about to show y'all some illegal math. Okay. So to factor this easily, if a is 1, it factors easy, right? When a is 1, factoring is very, very straightforward, correct? So the problem here is I want to get rid of this 3. So here's what I'm going to do. I'm going to take that 3 and multiply negative 10 by 3. Here we go. Illegal math. X squared plus X, and 3 times negative 10 is? Okay, so here's what's just happened. I multiplied the constant by 3, which means later on I need to undo my illegal math. So later on, we're going to hold on to that 3, and you're exactly right. So since I've multiplied by 3, I'm going to hold on to that, because in a minute I'm going to divide my constants by 3 to make it right. Okay. Okay, so I need a product of negative 30. This hasn't changed. They combine to 1. This hasn't changed. And those numbers are? Well, here's the deal. A is 1. If my numbers are 6 and 5, it factors easily, right? It factors into X plus 6 and X minus 5. And this is true. If I was to factor this red equation, this is the answer. But the red equation is not my problem, is it? Okay, so a while ago we multiplied by 3. We're now going to fix it. Because I multiplied the numbers by 3, I now need to divide the numbers by 3. I have 2 fractions, correct? Do they reduce? One of them does. If they do, they must. Got it? If they do, they must. So this one does reduce. Okay, so this one becomes? Does this one reduce? Okay, then I got to get rid of that 3. So I'm going to pull that 3 and stick it right there. It's factored, folks. That's the answer. Yeah, this works. If it's factorable, right? And if it doesn't factor, what do we do? Complete the square if you want to do hard work, or quadratic formula that always works. Okay, so there you go. So we did some illegal stuff. We took the coefficient and multiplied the constant by that. We held on to that number because later on we divide the constants by that. If it reduces, it does. Now, a side note here. What's that? Okay, so if we had, notice I've changed colors. This is totally not related to this problem at all. Okay, let's say I had X plus geez, I don't want it to be perfect. I'll just make it improper. That's what I need. That'll work. Okay, do those reduce? They reduce, right? Okay, so this one reduces to X plus, and this one reduces to, and they don't reduce any further. Okay, these can't be fractions when we get done. Okay, so if we reduce to the point where we still end up with fractions, that 2 comes over here, this 2 comes over here, which gives us 2x plus 15 and 2x plus 11. Okay, so but you have to reduce first. Reduce first and then get the denominator to the front. Okay, anyway, moving on. Back to the grouping method. If we were factoring this using grouping, we would see that this first pair has what in common? A 3x. So this first half, I pull a 3x out of it. So that gives me 3x times x plus 2. And the next pair, what do they have in common? 5, but because the first one is negative, it would be a negative 5. Take out a negative 5, what's left? Okay. And from there, folks, we get this, right? Both of those terms have an x plus 2 in common. If I take out the x plus 2, I'm left with 3x minus 5. Now that it's factored, we set each factor equal to 0, and they actually showed the steps there. So 3x minus 5 equals 0. Add 5 to both sides, divide by 3, x is 5/3. If x plus 2 equals 0, subtract 2 from both sides, x is negative 2. So the question says for part A to find the zeros, did we? Yes, the zeros are negative 2 and 5/3 to put them in order, small to large. Okay. Part B. I want to find the zeros of that. Well, to find the zeros, that means g of x, which is y, needs to be 0, correct? So 0 equals the square root of 10 minus x squared. To find the zeros, I have to get x by itself. What would be the next logical step? Can't. It's trapped. I need to untrap it. How do I get rid of a square root? Square it, right? So if I squared both sides, this is going to tax some of you. 0 squared is? Okay, I did a lot better than I thought you would. Just kidding. Okay, I want x by itself. What would you do? Add x squared to both sides. X squared equals 10. Next step, I want x by itself. Take the square root of both sides. What is the square root of x squared? X. What is the square root of 10? Okay. It's not a perfect square. There are no perfect squares that go into it. Let me ask again. What is the square root of 10? 2 answers. Plus or minus the square root of 10. That's the answer, folks. It doesn't simplify, but there has to be 2, right? Because if I plugged the square root of 10 in, the positive one, let's plug a positive square root of 10 in here. What is positive square root of 10 squared? What is the square root of 10 squared? 10. What is 10 minus 10? 0. What if I put in a negative number here? A negative times a negative? So I still have, so I have a negative square root of 10 times a negative square root of 10, which would be positive 10. What is 10 minus 10? Still 0. Okay, so the answer to part B is x equals plus or minus the square root of 10. Part C. H of t is equal to 2t minus 3 divided by t plus 5. Okay, I want that to equal 0. So 0 equals 2t minus 3 divided by t plus 5. Let me ask you this. Can the bottom ever be 0? No. If it was, what do you have? It's undefined, right? So in this case, and the book does it a little different, I'll talk about it in a minute. Because I know the bottom can't be 0, I'm actually just going to ignore it. Okay? I'm just going to ignore it. So let's look at this. What were you going to say, Caddy?
Would you not write that t cannot equal negative 5?
I'm not trying to solve it right now. I want to know the zeros. Okay? So if I was solving, then yes, that's very important. If I wanted to know the domain, that's very important. But that's not what we're doing right now. So if 0 is equal to 2t minus 3, how do I get t by itself? Add 3 to both sides, and then? So t is 3/2. Okay? And those are the answers. It can't be 0, so I ignored it. Yeah. That's correct. There's only one. Now, because Pritt is so confused, and some of you might be as well, the book does it differently. Okay. To me, that doesn't make sense, but let's look at their explanation. So here's the explanation of number 1. We got zeros at -2 and 5/3, just like they did, but they graphed it so you can see them. Okay. Moving on to part B. Part B, we squared both sides. We added 10 to both sides, added x squared to both sides, took the square root of both sides, plus or minus square root of 10. And that is the graph of a half circle, semicircle. That is the equation of a semicircle right there. Okay. And that's what we got, right? Okay, so for the confusion you might have on part C, well, here's the, they just, never mind, I need to scroll down first. 1 second. Here we go. There it is. Okay. Here's what happened to the bottom. If I have t plus 5 in the bottom and I'm trying to solve it, to simplify this fraction, I would multiply both sides by t plus 5. If I multiply the left side by t plus 5, the t plus 5 canceled. If I multiply the right side by t plus 5, I have 0 times t plus 5. There you go, it's gone. Okay. And then the rest of the steps follow. So there's that. If y'all are screenshotting it or whatever. And honestly, a lot of stuff, if I'm not writing anything, there's really no sense in screenshotting it because you have this full document. This is that 500-page document, whatever, that I gave you at the beginning of the semester, 400, however many it has. And here's the graph of that. And you can clearly see that there's only 1 0. Questions on those? So talking about when a function is increasing, decreasing, or constant, this picture already has it drawn out for you. Remember, in the United States, we tend to read from left to right. So when I'm talking about when is a function increasing or decreasing or constant, I'm talking about the domain. As you're walking along the x-axis, what is the graph doing? Okay, so this graph, if I'm walking along the x-axis right now, it doesn't exist, right? And all of a sudden, there it is. From -2 to 0, it's decreasing. From 0 to 2, it remains constant. From 2 to 4, it's increasing, and then it stops. It's just gone. That's the entire function. Okay. Pretty clear what increasing, decreasing, and constant mean? So here's the algebra piece to confuse students. If a function is increasing, that means if I take a smaller x value and compare it to a larger x value, then the smaller x value is also going to have a smaller y value, because as x increases, the graph's going to get bigger. So here it is in letters for y'all to admire and study if you want to, and I'm done with that. Anybody want me to spend more time on this? No. Okay. Well, this is the last day of the week. This is all we got. To help you decide whether a function is increasing, decreasing, or constant, you can plug in a bunch of different x values and see what the y value does. If it's increasing, then it's increasing. If they're decreasing, then it's decreasing. Okay, so on. However, we can actually use calculus and determine what intervals it's actually increasing, decreasing, and constant on. Okay, so again, we're throwing calculus at you there. Okay. Okay. Definitions of a relative minimum and a relative maximum. Relative means close by. If I am a relative maximum, like my current height, as I walk around the room, my current height I am a relative maximum. I'm taller than all of y'all because you're sitting down. Right? So right here, I'm relative to those around me, I'm taller. Everything around me is lower. I'm a relative maximum. Okay? Now, I'm a relative minimum. Everything around me is taller. Okay? I can sit on the floor. Oh, it hurts getting up. I'm an old man. Okay. But I'm talking about people. Okay. So here's a graph. I'm going to go ahead and just put arrows on this thing. So by doing that, I'm saying that this graph from here, it just keeps going this way. And then from here, the graph keeps going that way. Okay. I'm not saying the curve stuff keeps happening. I'm saying from here on, that's where it's going. Okay. Noticing this graph, this point has a relative maximum here. A relative maximum exists right here, which means the points close to it are all lower than that point. At this point here, I also have a relative maximum. The points close to this point here are all lower than it is. Does that make sense? The plural of relative maximum is relative maxima. That's why you see maxima, because there's more than one. That's the plural of maximum. Okay. Reverse everything I just said. I have two relative minimum. Okay. Now I put arrows on this graph for a reason. If from here, this line goes up and goes on forever and ever and ever and ever, this graph does not have an absolute maximum. Does that make sense? An absolute maximum or an absolute minimum, there can only be one. Okay. Correct. I'm now going to terminate. So this graph has terminated. Now, pay attention here. These 2 points are still relative maximum. However, this relative maximum is actually an absolute maximum. That makes sense? So I can still refer to them as relative maxima. Now I can't talk about this one being one because it doesn't have any points on the other side. It's got to have points on both sides of it. Okay. And I can't talk about this one because it doesn't have points on both sides of it. Okay. Does this graph have an absolute minimum? Does it appear that this point right here is in fact the lowest? Okay. So these two relative minima actually consist of the absolute minimum. Okay. Pretty straightforward. We'll study a technique for finding the exact point at which the second degree polynomial function has a relative minimum or relative maximum. For the time being, we're going to use a graphing utility to find reasonable approximations. Okay. Letter A. We're going to talk about increasing, decreasing, and constant. Letter A. What is that graph doing? Is it ever decreasing? Is it ever constant? Letter A is constant? It's not constant. Okay. Huh? Well, if it actually flatlined like this. Okay. Okay. It appears to be. This is the graph of x cubed. And if you plugged in like negative 0.1 cubed, plug in positive 0.1 cubed, obviously positive 0.1 cubed is going to be up here. Negative one's going to be down here. Okay. The function x cubed is always increasing. So when is this function increasing? It's increasing on the interval negative infinity to infinity. It's always increasing. Is it ever constant? No. Is it ever decreasing? Man, it makes no sense. Okay. Part B is part B, and let's go ahead for all of these graphs, assume that they go on forever, okay? So for part B, is it ever increasing? When?
At the very beginning.
Huh? Everything on the right side is increasing?
Before -1, 2.
So where did it start increasing?
Negative infinity.
Negative infinity. So this thing started increasing from where?
Negative infinity to -1.
All I care about are the x values. I don't care about what y is, other than the fact that I know that it's increasing. Okay, so it's increasing from negative infinity to, okay, parenthesis or bracket. Nope. But here in a second, you're going to tell me it's going down at -1. You can't be telling me it's going up and down at -1. That makes no sense. Okay, this is a parenthesis. Now, is that the only area in which this graph is increasing? Where else is it increasing?
1 to positive infinity.
Okay. Is this graph ever decreasing?
Yes.
With what kind of marks?
Um,
Parentheses. Okay. Is it ever constant?
no.
No. Number 2, are we increasing?
Yes.
Would you slow down?
Yeah, you're decreasing from 2 to negative.
What?
I had to read Jacob.
You're not decreasing from 2 to negative infinity.
But it's going down.
The x isn't. All I care about are the x's. Okay? All I care, I don't care about my x's, but that's another story. Okay.
I thought you were about to start singing. I
I think they do. Okay, so here's the answers from the text. So, and that's exactly what we said anyway. Average rate of change. Average rate of change means what is the slope between 2 points. So a graph can be doing all kinds of weird things, and I want to know what is the average rate of change from this point to this point. Yeah, I know the graph was increasing. Yeah, I know it was decreasing, but on average, what's happening? Okay, and that's simply going to be the slope formula, right? Except instead of y's, they're going to use f of x's, and their slope formula is really ugly. Okay, and so here's their slope formula. Okay, but isn't f of x sub 2 just y2?
No.
And isn't f of x1 just y1?
Over x1 minus
No. Got to keep them together. Okay. So I don't care if you use the f's or the y's, whatever you're comfortable with. The 2 points that go through that graph is actually called a secant line. So if I've got a curve and a line goes through that curve, touching it at 2 points, that is called a secant line. So when I'm asking for the slope, instead of saying m equals y2 minus y1 over x2 minus x1, I'm going to say m subsecant. So I'm asking, what is the slope of the secant line? That's why you see that right there. Okay. So subscripts typically let you know that I'm talking about something specific. It's not something you can actually use for calculating. So here's a graph. 2 problems. I think for time's sakes, I think we'll do 1. Right? Yeah. So we'll do A. So what is the slope of the line from x1 equals -2 to x2 equals -1? Okay. So we have x1, y1, right? And we have x2, y2. So in looking at part A, the x1 they gave me is -2, and the x2 they gave me is -1. Okay, so what is the y value? What is y sub 1? What is the y value that goes with -2? Okay. -2, -2. And what is the y value that goes with -1? Okay. I have to find the slope of this. The slope of the secant, right, is y2 minus -2 divided by
-1
minus,
-2.
okay, 2 minus -2, which is, okay, does it appear that the slope of this line is 4? Is this line going up? Is this line steep? Does 4 make sense? Okay. Time's sakes, I'm going to skip the other one. You can watch the video from the other class, and I did both A and B. Okay. There's the answer for the first one. There's the answer for the second one.
This is
Okay. Questions? No questions at all? Okay, so. Okay. Okay, let me go and stop the recording.